Tonight is October 13th, 2021. I'm going to document something quickly, I hope tonight. It's one small thing that I've been asked before, and it's actually quite important, I think. What if you want to light up a couple of tubes like these that are 10 volts, 5 amps each, somewhere between 4.5 and 5 amps, whatever. 10 volts at 5 amps, pair of them, that's 10 volts at 10 amps, that's 100 watts. How do you do that if you don't have a 10 volt transformer, if you don't have a 10 volt 10 amp transformer? Well, I showed this transformer last night. That's a 26, excuse me, I keep saying that wrong, a 24.6, which is a 12. It can be wired 24 volt 6 amp or 12 volt 12 amp. I've got it wired. See how I've got everything parallel here? This will go to the filaments, center tap. Okay, well, to get you really close in the ballpark, here's what you do. You know, because it says so right here, that the input is 115 volts. So what you do, I'm trying to get this thing back in order so when I plug it in I don't blow it up. What you do is you find out the turns ratio, which is the same thing as the voltage ratio, and it's 115 to 12. 115 enter 12 divide. There it is, 9. Get the damn. I need a cameraman. There's its turns ratio, which is the same thing as the voltage ratio. Now, if we multiply that times 12, what we're going to get is 115. That'd be the input voltage. What if we multiply it times 10? That's 95 volts. 95.8 volts, whatever. We enter that, and we'll just subtract that from 115. Yeah, 115. Swap that around. Subtract. See, we get 19.1667. We'll call that 20. We want to drop the input voltage by about 20 volts. That's what it's telling us. Now, this happens to be just a really cool example right here. We want to drop the input by 20 volts. Okay? Now, the tubes draw 10 volts at 10 amps. So that's 100 watts. So at 10, so what am I trying to say? I want to say it as smooth as I can. This 20 volts, the amount of current that we're going to be drawing on the primary is approximately 1 amp. It doesn't have to be exact. Don't drive yourself crazy with too much of the tiny detail, because you just kind of get lost in the weeds. These tubes draw 100 watts, so 100 watts at 120 volts is about an amp. So we estimate. Okay, so if we drop 100, if we drop 19, call it 20, if we drop 20 volts at 1 amp, we need a resistor that's R equals E, which is 20 over I, which is 1, which is 20 ohms. It says if we put a 20 ohm resistor in series with it, we'll drop it. Here's one that I've adjusted to 20 ohms. This is a 100 ohm resistor, and I've adjusted it to 20 ohms here. And I'm going to put that in series with the AC line. Just clip it in series here with my suicide cord, as I've always called them. Okay, and I got that hooked to the 115 volt side of here. Now on the output side of it, we have to put a load on it, because if we don't, well, I don't know what we'll get. We'll probably get the full voltage. Well, obviously we will. So what is the resistance of these two tubes? 10 volts at 10 amps, 100, it's 1 ohm. Okay, well, guess what I happen to have here? A 1 ohm resistor. It says it's 0.6 at 105 degrees, but it's actually 1 ohm when it's cold. Okay, so let's put our very accurate meter across it, and let's plug it in. Let's see what happens. Put this on volts. Plug this thing in. And there's our voltage. You got to see that. I need to, I think, move the camera up. Sorry for the fumbling, but You got to see this. Because if you don't see it, it won't make sense. Okay. And what I'm going to do is I'm going to put that 1 ohm resistor across it. See, that's our voltage now with no load on it. But I'm just going to touch here. What I'm going to do is go back down here. I got to zoom back out. I'm just going to touch the 1 ohm resistor right here. Let's see, I may can clip it in there. At least get it to stay in there a little bit. So this is simulating our tubes. We want to simulate it first. We don't want to, well, they've got some sparkles there. We don't want to blow our tubes up. Okay? And now look what our voltage is. That resistor is heating up a little bit. I think it's dropping slightly as it heats up. Well, anyway, it's 10 volts. We're there. Now, this isn't exactly perfect in every aspect, but you can see we've got really close to the ballpark. Okay? So let's take that back off. See, our voltage went back up with no load on it. Hope this is making sense. You've just got to do the ratio of what input and output is and get that turns ratio, and then decide what the input voltage should be for the output voltage that you want. Determine how much current is flowing through it. Do simple Ohm's law and calculate a resistor. Now we do have another very important step we got to go in calculating this resistor, and that's its power. Now its power is I square R. Well, remember that I is about an amp and R is 20 ohms, so I squares 1 times 20 is 20 watts. So it happens to be 20 volts we're dropping, it happens to be 20 ohms, it happens to be 20 watts. This probably isn't 20 watts of that resistor. So I may have to work with the resistor a little bit more. I probably want like a 50 watt. Like a 20 ohm. I'd like to have I think I'm going to try to find like a 25 ohm adjustable, you know, so I can tweak it right in. But I'm comfortable enough with it right now, I think, that we can light the tubes. I want to see these things lit. I haven't lit these things in eons. Let's prepare for the drama here, and let's hope that nothing blows up. If I burn the filaments out, I'm going to scream. Let's get the lights out so we can actually see it, and we'll watch the voltage and everything. But I'm going to drag them over here. Make sure they're in the view of the camera, and they are. And I'm confident enough now that I could connect them up here. I guess I gotta make sure they're making electrical contact there. Let's see what happens. Here goes. Wow, cool, huh? There you go. Looks about right to me. Aren't those things, aren't these big old tubes just neat? I really should be a little bit more worried about what my voltage is. But the voltage happens to be, I did not stage this before. I promise you I didn't. I'm just lucky. I really am. I'm just lucky right here that everything is working out like that. And there's our voltage across them. That ought to be close enough, huh? I'd rather it be 10.2 than 9.8. I'll tell you that. Especially tubes, probably these tubes probably built in the 1940s. So anyway, what the whole purpose of this little video is how to use a transformer, how to when you don't have the right filament transformer to light your tubes up, and if you're dealing with big guys like this, That's what you could do. You could use a transformer a little bit higher voltage and just calculate what kind of a dropping resistor you have on the, probably best on the primary. If you calculate it on the secondary, you end up with 0.2 ohms. So I guess you could put 0.1 ohms in each leg, but they're also at 20 watts. So you can't cheat the watts. But there they are. So I've got a bunch of these guys, but that's what they look like, all lit up. I just think they're just about as neat as they can be. So I hope that helps answer very specifically that question. And I was asked some time ago, I don't remember who asked it, but well, that's how would I go about determining what size a dropping resistor to use? Don't forget to calculate the wattage of it, and don't do this. Don't try to determine this type of the resistance value with something like let me see, what have I got up here? With some beautiful instrument like this. Better unplug that. Just turn that light back up. Yeah, don't do that with some really nice instrument like these decade resistor boxes, because you're going to smoke the resistors in them. These are not 20 watts. I think they're probably 1 watt. Maybe 2. I don't know. It tells you the maximum amount of current. 160 milliamps. Not 1 amp. 600 milliamps and 1.6 amps max. Well, you could use it down here. You could, but you know, do it in something. Use a resistor. Well, if you're just not really sure, use something that's expendable, but make sure you calculate the power. Stay safe. Today is October the 21st, 2021, and I've redrawn the schematics with a little bit better. And there's my cell phone going off. I've redrawn the schematics a little bit better here. This is the amplifier. I've taken into consideration all of the suggestions you guys have given me. I thank you so very much. You've made it safer. Well, for one thing, to keep there from being high voltage, when I say high voltage, I'm talking about 120 volts on these two wires. I'm going to put a double pole, double throw switch in here. Excuse me. And operate a relay back here. This one has to be redrawn again. I draw schematics by computer sometime, but I have a lot of these little drafting templates, and this is actually what I prefer to use. I have lots of these, just about every size in the world. But I thought I'd show you guys some things that newcomers may not know. You know what this is? That's an erasing shield. Like, say I want to erase, just for example, say I want to erase that 10 volts. I can put this thing down here in whatever way. I may have to move it around a time or two, but and then so you can get an eraser. Good erasers are hard to come by. The ones on pencils are like these things right here. These things are horrible. These things are all dried out, and all they do is smear everything. But anyway, you need a good eraser, and you lay this down there on whatever part serves you best, and you can get down in there really hard and erase, and erase small things without disasterizing your whole schematic. And the last thing I'll go with right now is this is a mechanical drawing pencil, and you know what this is? This is a mechanical drawing pencil sharpener. I don't know how many of you have seen that. And you just put your pencil down in there, and then I don't know if I can do it. I need to kind of hold the base of it. If I hold the base of it, but I can't do that with my other hand. Anyway, you spin this thing around like that, and it sharpens your pencil. Remember, I went to college and took these kind of courses in 1967, so that's being 54 years ago. We did things a little bit different then. I'm not saying it's better or worse, but we didn't have computer-aided drafting back then. So there you go. Eraser shield, and got to have an eraser, and all these little templates. And you know what? It's actually a lot of fun. It's actually kind of soothing to to draw out these old schematics mechanically. Back in a minute. Tonight is October the 18th, 2021, and here is the 810 amplifier that I've been talking about. Tommy and I have been working on this thing, I guess, about 10 hours a day for the last couple of days. Some of the components were ready for us, and a lot of it wasn't. But anyway, this is the power supply right here. It should deliver us about 2600 volts. And how do you like this on-off switch right there? That's for real, isn't it? And here's the amplifier. This is plate current, and this is bias voltage right here. There's the 810s in there. I know they're not lit up yet, but they will be in just a minute. We have not powered this thing up yet. The only thing that we have powered up, well, we've powered up this unit, and we know we have filaments and bias. And it's set up so that the high voltage cannot actually come on here until there's bias coming over here via this umbilical cord. Let's look in the back of it. Can we spin this thing around a little bit here? Because we can get a pretty good view of it like this. AC. The IEC top connector is a 15 amp fuse. High voltage on the safety ground to the other chassis, and there's actually two more wires in here that are ground. So we got 3 ground wires running between them because we do not want them to come apart. It's not plugged in. This is plugged in, but the other end is not plugged in yet. There it is, right there. Power supply. I know that is a small choke. It's 1.5 Henrys, 500 milliamps, which is what it loads down to under full load, 500 milliamps, thereabouts. This is a 2000 volt transformer into a bridge. I don't know how well you can see the diodes over there in that bridge. Yeah, you can see the 4 diodes right there. These diodes are rated at 20,000 volts PIV at 2 amps. But this is completely isolated from the chassis, even mounted with nylon screws right there. So the choke is floating. I've done that a number of times. That works when you can float the power supply choke if it's not insulated well enough to ground. This is the series resistors right here in that yellow shrink tubing. There's 6 1 megohm resistors in there because our meter right up here, our voltmeter, is a 500 microamp meter movement. This is the main power switch, and this is a switch in series. I know it's not real well lit in there. The switch right up there is to turn the high voltage on, and our big indicator is not wired up yet. We'll do that some other day. Let's look down in the chassis. Can you lift that off, and I'll show you quickly inside. We're going to drive it and everything. Here's the variac for the bias supply. There's a bias transformer. There's a choke for the bias filter network. There's the filament transformer. It's a 12 volt 12 amp, and I have some resistors on the other side that it needed a 20 ohm resistor in the primary lead to change the voltage to 10 volts. Here's the 2 let's see if we can get a shot of the 810s here. Right there they are. Plate leads up here on the top, and the grid leads down here. There's a driver transformer. There's those massive 810 transformers I've had for almost 50 years. So we powered each unit up separately, but we have never powered them up together. We've never put high voltage on this unit. We have seen the high voltage come up on this one, and it comes up to, with no load, I think about 2800 volts. So we shall see here in just a minute. Got handles on it to pull it out, see how they fold down. That's really nice, isn't it? Here's our dummy load over here. We're going to use these dummy loads. All right, now we're going to test it at 8 ohms. These resistors are 8 ohms each. Everything's 8 ohms, so we got 4 here and 4 in series, so we got 520 watts of plate dissipation. And if it works, we're going to celebrate it with a little bit of this. Just a little bit. Alright, I'm going to have to stop, and we're going to have to pay attention. I'm driving it right here from a dedicated line right out from under my power meter. This is number 10 extension cord where I can get 120 volts at 30 amps without turning the lights off, tripping the breaker. So we're going to very carefully power it up. Maybe I can get the camera over here in the corner so you can see it powered up. Oh, and look at this beautiful little amplifier that Tommy's built right here. This is to drive it. So the guitar plugs in here. It's a very nice little high gain amplifier. It runs, what, push-pull 6V or 6L6?
6L6.
6L6 push-pull in there to drive it. Really pretty. I don't know if you can see in the back or not. Can we see in the back of it? No, it's all covered. It's very nice. Okay, I think we're ready. We're expecting, hoping for about 700 watts. So stand by, and we will check our hookup a few times, and then we'll start powering it up. Okay, well, there may be 2 or 3 videos that I have to put together, but okay. This is the first time we're gonna turn it on.
Right on.
You do the honors. You're the big guy. Okay, and that's exactly what should happen so far. Nothing. I'll turn this one on. This one should give us bias and filament. Nothing.
No.
We have it plugged in. Did we plug it in at the other end out there?
Let's double check.
Okay, let's start all over here. We may not have plugged it into the main outlet to that big yellow plug. Oh, okay. Well, actually, I ought to be able to see it here. If this, yeah, this is lit up, so no, that's working. Okay, we don't have a blown fuse. It doesn't look like. So this should give us AC over to here. Do we have AC over there? We don't know. And because this should, the filament should come on and the bias should come up.
We also don't have, there's no, the fuse indicator's not on.
It shouldn't be, because if it's on, the fuse would be blown.
Oh, it's the other way around. Gotcha.
Yeah. Okay, well, we got something silly. Stop the cameras from rolling and let's see what we're doing dumb here. Okay, we're back again. We only had one wire out of place. I've been saying it's either going to do nothing, it's going to work, or it's going to blow up. So it's already done nothing. So the next best thing would be to work, right? Alright, let's try this again. And we don't want to turn the high voltage on yet. We should get filaments and bias. Alright.
Yes.
Yes. Our bias is a little low. We want it at least at 60 or so. If you will view the front of this thing.
I got you.
Let's see, I think if I... Okay, well, I can see it too, I guess, 50.
Cool. Yep.
Let's run it up a little high, because our voltage is going to be a little high. We'll set it up at 70, because it's supposed to be minus 60 at 2250, and our voltage is going to be a little higher at 2250. Do we dare turn the high voltage on now?
Let's do it.
Well, I'm going to keep my finger on it in case it goes kapooey. Are you ready for this? Yeah, we got high voltage.
Right on.
We're at 2700 volts. And our bias hardly dropped. Oh, yeah, there's our plate current.
Yep.
Yeah, we got 40 milliamps of plate current. That's correct.
That's
well,
good.
then,
Good
well, I don't
resting.
know if that's the right number. We got to adjust the bias. The bias is a little negative, so our resting plate current is a little low. That's good.
That's awesome.
It's working. Okay, where's our data sheet?
Right
Here. Okay. The maximum resting plate current should be about 70 milliamps. Okay, let's run this thing up a little bit. Resting plate current is 70. It's 20, 40, 60. So 70 milliamps. And our bias voltage is 65. You know what that says? That says our tubes are good. Our high voltage is a little high. It's almost 2700 volts. But that is possibly because we do have to check the accuracy of our high voltage meter, because I just put, it's a 500 microamp meter movement for 3 kV full scale. So I put 6 1 mega ohm resistors inserted, and they're all 5%. So we're going to turn it off right now, and what we hope to see right now is the plate voltage drop rapidly, because the tubes are going to load it. Let's see if you can see this. No, this is good. I don't see any red plating or anything. No, we don't see that. Let's turn some of the lights off. Good. I don't see anything red in there. I wouldn't expect to. I think we're going to turn some lights back on now. Okay. What we want to see right now is we do not have any heavy bleeders on it, so I'm going to put the camera right here on the high voltage meter. And as soon as we turn this high voltage off right here, we hope to see it drop rapidly. Well, it's not dropping as rapidly as I thought it would. So we may have to put the relay in there to put a heavy load on it to bleed it down really quick. Yeah, that should be at 0 by now. Okay, let's turn the high voltage back on. Now we're actually working. We've got it on a load. I think the next thing to do is we got to drive it a little bit. Let's see what happens. Yeah, we had a wire on the wrong side of the bias sense relay. Wonder what the temperature of those things are. Let's see what the temperature of our tubes are. I guess my battery's dead. I guess I gotta put a new battery in it first. Okay. Well, that's the first power up. That's this is good. We're not through yet. Okay, we have this thing cooking. We had a bad tube. One tube, this one here in the front was working. Actually, you can see that they're very, very hot. I don't see them red plating here though. This tube is good. It's original. The one in the back is bad. Was bad. And it's over here in the corner. Upside down right there. Poor thing. It's no good. And what we're getting out now, we'll crank it up to just below 500 milliamps. Plate current. A little bit more. Right there. And here's our power. 650 watts. Our distortion is 14%. Here's what it looks like. We know that's not perfect. Our plate voltage is, and we've already checked this is reasonably accurate, is just a hair below 2300 volts. We're driving it with this pretty little amplifier. It's very high gain, and we've got the oscillator, this SD505, down as low as it'll go Yeah, minus 60 dB. There it is. That's what a pair of 810s will do. Yeah, this, I don't see that they've got any red plate in them. Oh yeah, and our, this is our dummy load, and it's smelling pretty bad. It's smoking. Okay, well maybe, yes it is smoking. Turn it down, please, sir.
Yes, sir.
Yeah, it's actually smoking. I don't know if you can see the smoke, but I sure can. Our resistor should be able to dissipate up to about 520 watts. Unfortunately, my battery's dead in this thing right now. Alright, show you the temperature of them. Maybe I should put a new battery in it so we can measure the temperature. Be right back. Okay, I'm not gonna. Okay, what we're doing here is I'm just picking off like 2 wires from the end of a 4 ohm resistor so that we get a very, very attenuated signal, and this is the way it sounds. Let me move the camera. Well, let's see, we don't need to move the camera. I want to put the camera on the plate current meter. If I can not stand in the way. And we'll put it across 2 wires of these big resistors. Well, I understand. I'll show them here. The little guitar we're playing. Here's the little guitar that we're playing right here. It's a toy, but the only thing we got is for right now. I gotta hook the wires back. Whoops! I'll hook the wires back up. I'd say it's probably about a 500 to 1 attenuation.
Yeah. Yeah, it's getting 300 watts.
They can melt into wires to the resistors. We got kind of a small problem. Let's stop just a minute.
Oh, red plate.
Yeah, well, yeah. Well, no, I want to see it, actually. Okay, no, that's okay. Yeah, the one on the left is, the tubes are not very well balanced. We might have to work on that. If you can see here, let's see if you can see here in the tubes. The new one that we put in, that has to be the one on the left in the camera here, is actually quite a bit red, more red than the other one. So it looks like it's doing the most amount of work now. A while ago it wasn't doing any because I guess it was open. So there you go, a little bit more data. Okay, we're still doing a little bit of testing. These are some new made in China, Chinese 810s. They're made by Taylor, I believe it is. They've never actually been turned on. I've had them for several years. We just got the filaments on there. We haven't put high voltage on. Thought we'd let them burn in just a little bit, so to speak. And we'll see what they do. And I'll show you the power here in a minute when we get there. I smell those things burning again.
Yeah, they're smoking a little bit.
Okay, well,
yeah,
that's another set of good tubes.
Cool.
Okay, here are some Westinghouse 810s. Let's see if I can get up here. So this thing, see, hardly any. This thing seems to accentuate the IR, and I don't see them turning red at all. Those seem to be the best ones so far at 615 watts. THD is 11. And that's what it looks like. A little bit of crossover distortion. Nice soft rounding. We want to call it clipping. This thing is running with absolutely zero negative feedback. Pretty amazing, isn't it? Okay, well here's its resting current without high voltage. Let's get the glare off of it. 1.17 amps. Okay, if you'll turn on the high voltage. A little bit of surge there, but settles in at about 3.5 amps. If you'll run it up to about 630 or 40 watts, because I know you guys got to know what the current is. It's actually pretty good, isn't it? What kind of power level are we at now?
605.
605, 600 watts.
That's peak.
11.5 amps. So you can even figure the efficiency there. Let's see, what is our input voltage? Input voltage is 114. Yeah, if we ran this up to 120, it'd be even worse or better. Okay, 114 volts, 11.5 amps. That's our input, and our output at this moment is 602 watts. So there's how we calculate our efficiency. And no red plating or anything, just shy of 440 milliamps at, gotta get everything here, at just shy of 2200 volts, 2150. And last but not least, and very careful, as sensitive as this little camera is to the IR, I don't even see the plates getting that hot. I think it's turned out pretty amazing. Pretty amazing.